Hello and welcome to the AI Digest. My name is Joaquin, and I have the great pleasure to have with me Magnus Bakken. Hi, Magnus. How you doing?
Hi, Joaquin. I'm doing fine, thanks.
You hail from Norway. What is there to do in Norway?
Right now, if you want to have a nice exercise, there is lots of snow to mow away, and uh, you can freeze or you can stay inside. There's a big Siberian cold front coming, so we're all huddling now, I think.
Sounds absolutely terrifying. But let's talk a little bit about your PhD. You recently completed your PhD, and you were telling me a little bit about this before we started recording about the focus of the problem you were trying to solve.
Yeah. So let's say instead of going into the technical bits of the PhD, let's look a little bit. I'll talk a little bit about these the sort of the background for the PhD work. The PhD is about using knowledge graphs in industry to support, let's say, value or applications. Um, and the background for this is that there's been digitalization going on in heavy industries. So let's say factories, process plants, energy plants for several decades. And in any such company, you would expect to find a lot of digital models of that asset. So when you do engineering, there's detailed engineering models covering nuts and bolts, equipment, process flows. There's maintenance systems that need to have a sort of a model of how the plant is structured, what kind of equipment you have. There's ERP systems, there's automation systems, and there's also sort of, let's say, naming schemes and standardization initiatives. So lots and lots of digital models. And the PhD is about how can we use these models to be able to build applications or that somehow help us manage these industrial assets.
So
Um,
when you say industrial asset, you mean like a energy production plant, right?
yeah,
Something that takes in input and
yes,
produces and distributes electricity or something. Uh,
yeah. So it could be sort of it could be a wind farm, it could be solar, it could be oil and gas, it could be more of a process plant which is taking something in and doing stuff to it, and then making some creating some output. So these are sort of the business setting, um, and the sort of the problem with these. Okay, so you have all these different models, but let's say not only do you have lots of models there, you could very likely have, let's say, a long history of multiple, let's say, power production plants being built to different standards. So you have different languages to talk about the same thing. And in addition, you have typically different technical infrastructure, different IT systems that are in, let's say, different stages of modernization. Um, and so you sort of you're cursed in multiple ways here, and this can quickly become a mess. And so what could you do? Do you do this really large IT harmonization project and say we can't deliver value before we have everything into the same system? That's sort of the recipe for never getting done. Yeah, it's you can have. I remember I've tried to sell things to these companies before, and they it's they don't have capacity to do anything while these projects go on. So that's sort of an old-fashioned way of doing things. Um, and the idea then in the PhD is that okay, this is of course not my idea per se, but you lift these models into a knowledge graph, and then you can start getting value from it in that way. Um, yeah. So for those, if there are listeners who don't know the knowledge graph term, it's basically, so a graph is you have nodes and edges in between, and then what makes a graph a knowledge graph is that you say, okay, the node is somehow referring to a thing or a concept, and the arrow or the edge is referring to some kind of relationship. So you use these graphs to represent knowledge about the real world, in this case, an industrial asset. And then lo and behold, you have what we call a knowledge graph.
I have a few questions. So you mentioned that there's a frivolous amount of models inside of a industrial context.
Yeah.
Now, what does that mean? Is that like a mathematical model? Is that like a simulation of like how input goes through this function of the system and it outputs and distributes the end product? How it's happening? What kind of models are you referring to?
Okay, so the model here is really, well, of course there are these kinds of models as well, but the models I'm thinking about are just models about how is this industrial asset composed of different types of equipment, what are the properties, the nominal ratings of this kind of equipment, how is this equipment connected in the process in order to deliver this produced good, or this how does it produce energy. So there, it's sort of describing this, but very often this is implicit in, let's say, a database schema in an engineering operating system. So if you're, let's say, an analyst wanting to just get some data, you have to learn about how this type of OT, operational technology, works. You have to know about how this database schema works. You have to read this diagram. You have to, so that becomes very, very laborsome. And as we was talking about, it's not even just one schema or model. You might have to. There might be 5 ways of doing this in the same company. So it's really a big problem, which is sort of keeping back how much companies are able to use their data. And so,
I have a quick question. How does this differentiate the modeling of the hardware, the physical infrastructure, the software, the metadata of the individual components of this? How does this differentiate from a digital twin? We had this conversation before, but you mentioned something about
So definition of a digital twin is somehow that you are able to create a model of some kind of physical asset, and that this is keeping track with the changes that are going on in this asset. And if you're being very strict, you say that, okay, if you're just keeping track, just updating it, then it's a shadow. It's like a shadow on the wall of keeping track of at least some aspects of what's going on. And then if you connect that back and try to use that model to, let's say, do what if analysis, to set parameters, to model things, then it's a digital twin. So that's the very strict definition. But of course, digital twin is being abused a little bit commercially, but that's okay. So it's not a very precise term.
Okay, I think this is leading us to talk about you being the co-founder of the Data Treehouse, and it's a bit of my head spins with all these different terminologies around data lakehouse, data warehouse, data
Yes,
everything.
the warehouse is where you put it. Data lake is where you swim. Data lakehouse is where you stay. No, so it's it's a play on these terms. So data warehouse is, well, okay, let's not go there. Data lake is somehow an unstructured store of data. It might have some structure, but you upload vast amounts of data there. And then there are technologies for querying that data which is in the data lake, which are called data lakehouses, typically using SQL, having to model things with the schemas a little bit here. And then the idea of the data treehouse is that we're sort of next to the data lakehouse. There's a nice big tree there already. We're putting the data treehouse in the tree, and then we have the higher vantage point of this data. So that's the idea. So that's sort of first this play on words, but then the reason, so the whole metaphor of the tree. So the data treehouse is really something we try to build on these existing models that we were just talking about, but also on existing infrastructure for storing large amounts of, let's say, time series data, events, alarms from these industrial systems. So we sort of can, we build on both the existing models and the existing infrastructure.
That's a fascinating idea. I mean, sure, a lake is where you dump all your data. Well, the slush of data coming from all the different applications and their own schemas. I mean, you buy some, you build some, you acquire some companies, but that data lake is where you kind of find a way to unify all these different sources of information, and it sort of lets you do version control, but for your database, uh, and the data inside of your database. Is that not the function of the data lake? Find a way to like just smush everything together, so you can take
Yeah, you
different.
could. Yeah, you could go that way and sort of, so, well, you can smush all things together. The problem then arises when you want to query it, right? So then if you want to have, let's say, SQL queries, you have to have everything on the same schema. Otherwise, you have to have lots of different SQL queries. The idea of this data treehouse is that we take this this model of the industrial asset, lift it to a knowledge graph, and this is contextualizing operational time series data coming from that asset as it moves into, there could be on-prem solutions as well for storing time series data, or as it moves into the data lake. So that's really, say, the core idea here is that this model is traveling alongside the let's say, more voluminous data. So that's the time series aspect. It's always bigger than the industrial asset. That's where the big data is.
And the difference between this and a data lake house is that data lakehouse is very rigidly looking across all the different schemas that have to do with a particular entity and trying to direct that via SQL complex
Yeah,
uh, SQL
we're
query to build like an endpoint, right? So you can get like entity resolution around a particular
yeah,
data.
yeah. What I think typically happens is that you have the data lake, and then you discover in your organization some kind of information need. And what you build often is a data mart. So then you have to do a transformation of that data in order to be able to, which is sort of purpose specific for a particular set of information needs. And
Hmm.
what we're proposing instead is that you build the knowledge graph, which is conceptually representing or using concepts
Real world.
from the real world, from standards, for instance, to describe and query the data wherever it resides. So you don't have to do this ad hoc uh, reformulation of the data
That
and
doesn't
data
scale.
movement.
The data houses don't scale. You have to build one, or you have to build some infrastructure up prior to being able to query it and then build a dashboard, right? It's sort of
Yeah, yeah,
like
yeah, yeah.
a key process where you
It's
have to interpret the data, build the infrastructure, and then it delivers value to the end user. But you're saying the data treehouse is a way to enrich the schema of what already exists, right? With the databases, it's
mm,
extendable, right? Knowledge graphs allow you to keep expanding and build richer relationships, richer context maps, um, but it's not using SQL.
Yeah.
right?
So it's using this. I mean, this knowledge graph is allowing you to use concepts, or let's say subject, verb, object sentences that lie much closer to how we talk in natural language about these assets. So that's sort of part of what's special here is this ability to do this hybrid querying. This is a contribution from the PhD to be able to query these and use the best parts of knowledge graphs or triple stores, these ways of storing knowledge graphs, and also leverage these analytical data infrastructures. And then to abstract away these technical details and have that be exposed in the same way. And so let's say the philosophy here, getting back to sort of this complex, building this knowledge graph of the industrial asset, this could be a very time-consuming and difficult project as well if you want to build the whole model perfectly to begin with. And so we have a more pragmatic approach to that whole business, where we want to be able to build. We start with customer needs. We start with these questions, and we build as much of this knowledge graph based on existing sources as you need in order to answer these questions. And when these are queries, this is so queries are a powerful concept, and it's really key to how you can do this incrementally. Because once you have that, okay, so you have modeled some part of your asset, so enough to answer a meaningful question. So that could be, okay, so you model in a solar power plant, you model enough to get the power produced by a bunch of solar panels, and also enough to contextualize and figure out what the solar irradiation of these panels was in that period of power production. So let's say you model this, you have enough as a solar power plant. There's lots of data there, or lots of stuff you can model. But let's say you start just with that. You can reliably across multiple solar parks. You can query just for that. I want to be able to find the power produced for a bunch of panels and the solar irradiation. There's these pyranometers that measure this stuff. Now you have a query that you could use to do something like statistical process control, to figure out, okay, what's normal power production based on this irradiation, this level of sun. We should see more power. Why are we not seeing it? You could do this stuff. So this is this would be then a SparkQL query. So now you're going from there's source data systems here. There's schemas and all this stuff. You build a sort of a quite thin process to get this stuff lifted into a knowledge graph, and you get the query and you get the data. Now you've sort of captured with the query the stream of value in your organization. And using just proper modern software engineering practices, you could nail that stream of value to the wall with a test, with an integration test. This means now you're able to incrementally, you could add new things. Okay, let's say you add temperature to that, because temperature is important for the efficiency of solar panels. Or you could add something else, which is important. But crucially, we think you should also be able to make a big mistake, a modeling blunder,
Those
because
would be smaller mistakes because there's lower stakes at play. No.
yeah, you could say that, because you're doing an incremental change. But you will also be, if you have the test, you will be alerted that you're not delivering this stream of value anymore. This is now gone, and you have to fix it. and there's a saying that all models are wrong and some are useful. So you're bound to be wrong. It's okay. And then you can do these iterations and see that the value is preserved. And we think this is really key to getting getting a good value from a knowledge graph investment. Second thing here is that okay, we're talking about, okay, you update the model, but we're also talking about modernizing IT infrastructure. It's the same thing. You're lifting some model that's stored in existing IT infrastructure to a knowledge graph, and then you're doing a query and you see that there's value. What could happen then is that, okay, you decide to modernize it. There's a new schema, there's a new vendor maybe for a SCADA system, there's a new power plant. Now we also have a check on that value. You want to, of course, if there's a new plant, you want this new plant to also have this check for misbehaving panels, let's say, and that would, yeah. Most likely scenario is it doesn't work, but at least it tells you that it doesn't work and what's wrong, so you can very quickly iterate to get, let's say, new assets up to scratch, so they are sort of integrated into your
What I really appreciate about the approach of of knowledge representation, of constructing knowledge graphs, of iterative development, is that it's closer. It's based closer to reality than it is to build this big hypothesis and work through a particular plan of action. Wait 3 to 6 months and do a couple of sprints, postmortems around the work that's being done. But it's not until the end of the project that the momentum is exhausted and you say, was this useful or not? What you're doing is you're hand holding with the business users an iterative, a very much active participation from them to see, is this report useful or not? Are you getting answers to the questions that you've asked? Yes or no? And you're very much quickly able to make the mistakes you need earlier on than you would if you had a predetermined 3 to 6 month course of action. Um, and this parallel seems to play out in the physical infrastructure, or the physical world where the industrial revolution took place, where we went from craftsmen to making batch processing, right? Like, I'm gonna make a rifle. Let me make all the triggers. Let me make all the barrels, and you have to invest in inventory. You have to do a bunch of crap work where you have to do the constituent parts, store them, and then jam them together to build the end product. But your way is more of the lean, modern manufacturing approach of just in time manufacturing, where you're not holding inventory, you're not bloated with weights or bureaucracy. You have the one order that you've been asked to fulfill, and you're directing all your attention to fulfill that one order. Um, and as the demand picks up, you extend that order and you make the process a little bit more elaborate. But I, I just think it's a very rational, very pragmatic way of maximizing your learning and reducing the overhead spent on something that is really like human centered, right? It's not, we're not serving the technology, we're serving the people that wield the technology.
Yeah, that's yeah. I enjoy it too. I've started. I'm teaching a little bit while I do this startup. It's there's not enough time, but I'm doing it anyway. So I came across a really nice report from, it was a government report ordered by the government of Norway in 2015, I think, from the Simula Research Laboratory, and a researcher there called Magne Jørgensen. He came back with some empirical. He did a study of previous work and figured out what are the main causes for IT projects to fail, particularly in the public sector. But I think it extends pretty nicely. And this key finding was that the size of the project, just the mere size of the project, and the notion that the project is being driven by value for the organization at each stage. These were his main findings. So the idea is then the project, as the project increases in size, the risk of failure increases. And if we sort of believe these promises that, okay, we have to just build all of this stuff first, and then in a couple of years, we'll see value. If we don't require value straight away, then we have a much higher risk of failing. And these large platform projects, these large infrastructure data platform projects, they have both problems. They're big, and with a platform, what you're saying is, well, the platform, it's not useful. It's not useful by itself. It's useful. It's a flat surface to build things. So it's useful because the flat, nice surface makes it easier to build things. But it's the things you build that are providing value. So if the platform has to be done before you can start building, then you might be in trouble. So there's this is very relevant in Norway now, because I was talking to students about this very large platform project in healthcare, where it's called the health platform, and it appears we didn't learn anything from the report, unfortunately, and it's I think 3 or 4 billion Norwegian kroners now, and it's really putting lives at risk, and yeah, so it wouldn't be it would be funny, but it's not, because it's really having these consequences.
That tends to happen with government contracts that are sort of just handed off, and everybody has the assumption that it's a lean operation. Sometimes those are bloated and filled with bureaucracy and approvals and lack of clarity around
Yeah,
making.
there's the Obamacare Affordable Care Act is the American example, right? So I think they call them the Beltway Bandits, those companies that are their main skill is in navigating this nice labyrinth of bureaucracy, and the whole package sort of for delivery is just so large that there's like 1 or 2 companies in the world that can deliver it. And so there's not much competition. And once you get the contract, it's just milking money out of the project. So, yeah, from our experience, what we prefer is these small platform projects that really have to deliver value right away. And so the both in terms of delivering value, but also in terms of delivering incrementally these queries, I think are the key.
Your expertise lies in hybrid AI, right? Combining statistical, so classical artificial intelligence, machine learning, number crunching, and also the symbolic AI, which is representing a domain, uh, modeling it, and baking it full of human-centered um, experience, right? With how they view the model of a system.
Mm.
So, can you talk about that in the context of the platform, and why it's important that you have that background and how that influenced your thinking in developing that platform?
Yeah, that's interesting. Yeah, so I would say that so there's lots of talk now about large language models, and And of course, it's a very realistic scenario for us also that we would use natural language to access this industrial data. But you can't run precise queries off of, let's say, a vector database or a semantic space, which is sort of sensitive to perturbations. It's
Word soup.
yeah, it's very useful, but it's not precise. So first you have to have this, let's say, precise way of describing the world. That's a fundamental aspect in order to, because you want precise questions. But the other part is how these questions can be quite tricky to formulate. It's dealing with these query languages. It takes a bit of practice. So I think there that the large language models can be really used to get going with formulating these queries. Yeah, so that's sort of, and that's, I think, the combination of let's say symbolic and subsymbolic AI is moving really in that direction, to be able to take the best of both worlds, take the precision of the symbolic world and take the on-purpose fuzziness of natural language as it's occurring, and to combine these things. So, but we're working on we're quite focused on this symbolic part, but we will be collaborating with others who are to sort of fill that complementarity.
Well, the benefit in what you're doing is that it's open source and it's based on the Worldwide Web Consortium standards, right? Standards that are recognized at an international level.
Yeah. So I always blunder with this, so I just say W3C, and then it's more easy for me. But yeah, so listen, we're a really small company, and for us to, I think we can really provide lots and lots and lots of value to large industrial companies, but we won't be getting there if we want to lock in our customers. That's totally unrealistic to try to be locked in by a sort of a shoestring budget startup. So that's why we think, and this is something also that we're finding in the market, that building on standards, having no vendor lock-in, it's really important, and it's getting much more important. We're seeing companies moving, instead of sort of going to this big non-competitive vendor and saying, okay, I want the whole package from you, and please lock me in. Companies are seeing that you want the best of breed systems. You want to be able to switch things out, and this is really something we can help with. So we're using our software is open source. And it's also using these W3 standards, so RDF for representing knowledge graphs. We're using Shackle for validating them. We're using SparkQL for querying them. So, and we're integrating also for the analytics geeks. We're integrating with Apache IO and these modern analytical data formats. So that's the yeah.
And this platform, the way that you can extract information is Sparkle, right? The graph-based query language as opposed to SQL.
Yeah. So
What is the
yeah.
what is the importance of being able to interface with the data lakehouse via a graph structure?
So very often, let's say, what we've found, or let's say science has found, is that our knowledge of the real world is tends to be well represented by a graph, and of course, and even for these industrial assets, I mean, it's things connected to other things, connected to other types of things. It's really naturally a graph, but let's say the SQL world doesn't just consider, okay, the ideal way to represent knowledge. SQL is about representing knowledge in a way that at that time was technically feasible to do. So you're mixing in the technical considerations with the knowledge representation needs. And with SparkQL, you're just focusing in on knowledge, asking for information. You're abstracting away the technical bits. So and with the PhD, I've found ways to do that for the combination of models of industrial assets and time series data. So it's the field is called ontology-based data access, and ontology is like the concepts you use to describe the world, and ontology-based data access, that means that we use our concepts that we use to describe the world to access data. So that's the main differentiator there.
And the expressivity of a query via
Mhm.
SparkQL versus a SQL query is that it's more akin to natural speech, natural language, right?
Yeah, it's more akin to at least concepts and natural language as well. I mean, you're saying this thing has this relationship. You're saying, so when you're formulating a query, you're saying this thing has this type of relationship to this thing, and this thing is of this type, and this thing is such and such. And then the query engine is just figuring out all ways to answer that question.
As
Whereas in
opposed
SQL, you're taking this database and you're saying, okay, this database, this table, I know that this acronym part no original, this means the original part number, and I have to remember that, okay, this is that one, and so that's all. The knowledge representation is more implicit, less accessible. So when you have industrial companies, you don't have one, remember, you have 10,
to
20 ways of doing this, and it's totally outside of what a machine learning engineer, data analyst, of course they are able to learn all these things, but
they have to.
they spend all their day then figuring out what's the right data and learning these 3 different ways of saying the same thing. Yeah, so that's the contribution of SparkQL.
Okay, and what's some of the work that you'd like to be doing in the space of industrial data contextualization? Where do you see yourself applying your work, your platform, your knowledge?
Say in the space of industrial data. So what we're really excited to explore is, as we were touching on that point a little bit earlier about, let's say, managing dependencies between what are called data products. And that's really something I think is key here. So we were talking about so a data product is something which comes from Data Mesh by Shamak Degani. I'm probably not saying that correctly. And the idea of a data product is that you have some kind of data source, and you're making something out of that, accessing the data, and then you're providing that to the rest of the organization in a way that means the rest of the organization can access it and do it in a self-service accessible way. So we can view this. So when we have existing data sources and we lift it to a knowledge graph, this is a data product, right? So you're taking all of these heterogeneous ways of representing something, and you're lifting it into something which is accessible to the rest of the organization. Now they can navigate and figure out what kind of equipment is in the properties of that equipment in the industrial asset. Then we can also view this query over this knowledge graph as, let's say, a virtual data product. So the query itself, not the answer to the query.
Infrastructure.
Well, it wouldn't be infrastructure. So it would be sort of the question. So you could say that I've taken the time and written a nice query, which is giving you, actually, it's computing a report that we need for the government, let's say.
Okay. Would that Sparkle query be baked into a REST API or something that you can hook into, or how does that work?
That's up to the organization. I mean, that's something that would be, but the idea is just that you could put it into whatever you like. But the idea is that if you have this query that's providing you with this answer, this is really powerful. This is something which is really scalable.
Mm-hmm.
This is something that means when you buy some company and you model it in the same way, or you start modeling an old plant in the same way, then this query allows you to also do this report for this asset. And so your original question, if I haven't forgotten yet, I hope not, was sort of how do you see yourself applying these queries or sort of applying this stuff, and this is something we really need in industry to be able to manage these data products. So when some machine learning engineer is did I cover this? I think we talked about this, that, okay, there's a machine learning engineer and they, maybe not. So if you have sort of an automation system in a process plant, naively, if you just put the data in the data lakehouse now, okay, there's a sensor somewhere here, or there's some kind of computed value in the automation system, and you do the naive approach and you just, okay, now it's in the data lakehouse.
You assume everything's working to specification. There's no mechanical or digital failures.
Yeah. Okay. So no, the automation system is working fine. It's just that the automation system, as it should do, is producing some kind of data point for every second, let's say, and you're storing that somewhere, and then now you're lifting it into, let's say, the IT world, not the operational setting, lifting it to IT, and then here comes along this machine learning engineer, and they're looking at this. Oh, this is what I need to provide value with machine learning for this organization. This is an important data point. This temperature measurement is very important to classify when something goes wrong, let's say. And then they make so then they take this data and they make some kind of analysis, and this is providing value. But the OT people, the people in the factory that are setting up this automation system, they're not talking to the automation people. And then, okay, they have to switch things around because we're adjusting the process a little bit. Now this value has a new name. How do you catch that? This is dependency management, right? So you have this you have this really dependency between two systems, two models, and so, okay, if you're in good shape, then at least you know that someone is using it. So you have to have the meeting and say, now this will have a new value. But probably not. Probably what happens is that we can't think about I don't have time for that. We have to do the change. We're not responsible for them. Do the change, and then stuff breaks. And then they have to, if you discover that it broke, you have to come back and say, okay, what's going on here? And so I think then lifting this, instead of using this magical name of this signal, or this temperature reading, you lift it to the knowledge graph and say, it's the temperature reading that's connected to this tank, for instance, or this, which is important in the process. And then when the machine learning engineer wants to access the data, they have to use a query to access this data. Okay, for this analysis, I need to find, for each tank, I have to find, among other things, this temperature reading. And so now the dependencies are there somehow in the knowledge graph and the query. So when someone does something to the automation system, this will break this chain, and the test will light up and say this is now wrong. So that's really something which is hard to do in these organizations. And this is a little bit interesting because now we're talking about data dependency, but I think there's lots of inspiration to be had from how we do, or how you could do dependency management in software engineering. So if you, so I was talking. I was reading this or actually listening to this. I think it was as an audiobook. There's a great book. I was also teaching this a little bit, called Software Engineering at Google, which is written by, I think, 3 Google engineers. It's about sort of practices that allow Google to do software engineering at the scale of, I mean, they must have hundreds of thousands of developers there. At least tens of thousands. And there's a fantastic chapter on dependency management. So traditionally, when you do dependency management in software, you do what's called semantic versioning. So do you know about that?
No, but it seems like you're going to explain it to me, and it has
And
to do with
yeah.
understanding like what you're representing and how it's evolving and rolling out.
So it's really a numbering system that someone came up with, where you say there's a web page with sort of a manifesto or a description of this concept. So you have a particular version number. So it's version 1.2.3, let's say. And depending on the type of change you're making, if you're making just a patch that shouldn't influence any users, it goes in the last digit. If you're making more breaking changes, you do the other digits. But what Google has found is that it's really hard to do this correctly. Typically, there are people are depending on your tools in ways that you didn't expect and didn't plan to. They have this concept called Hiram's law, which is saying that given a sufficient amount of users, any feature in your endpoint or API or is dependent on by somebody. So somebody is depending on this to have high performance, for instance. That could be something. So that's and really that's just a number, and you're packing a lot of information just into one number. You're saying it changed somehow, but it doesn't. Even though the API has changed sort of in a breaking way, doesn't mean that every user of that API will experience an outage or not be able. They might not use that feature which was changed. So a lot of things are packed into the number, and Google have found that it's sort of hard to run their dependency management on that concept. So okay, so now the solution for Google, it's the Beyonce rule. I have now a 7-year-old daughter, and she's listening to all of these. So this is now from the song called "Single Ladies." Don't think we've listened to that yet, but the idea of Single Ladies is that if you liked it, you should have put a ring on it. So if you're in, you liked the guy at the bar, then you should have then married him and put a ring on him. Otherwise, the single ladies will come and get him. So that's the idea. But transfer to dependency management, that means if you used some kind of library, and in our case, if you used the knowledge graph to derive some value, you should have an automated test. And if there is no such test, then we are allowed to do changes, and it's on you to adjust to these changes. So this is how Google are able to at scale do these changes. So someone makes a change in a piece of software, and then they're actually running all of the tests of every team that depends on that piece of software to identify how this affects users. And oftentimes they're able to go into the code of users, because the people who are making the change to the library, they understand the change very well. So they can even in automated ways go into the users and say, okay, this should be this now, and this should be changed in this way. Just and then maybe they have to have a meeting or two with some teams that are doing it in a very special way. But that's the key here with the knowledge graph. Also, I think with these dependency management in to really get things scaling with using data in industry, I think you need to have these concepts, particularly in the some of the large companies we're talking to.
So if we were to go from scratch to a new engagement, say Bakken Solar Panels Incorporated,
Yeah.
go and their solar panel farm, we'd say we can help you scaffold a platform that helps you build reports and helps you model the real world in your digital infrastructure around the information you already possess. Um, we start by creating an ontology around the things that already exist in the schema, the documents that they share with us, the reports that they're producing. Um, and from that ontology, we can build a knowledge graph that ties back to the data. And we build that semantic layer, that layer of meaning above uh, the data infrastructure that allows us to create a Sparkle endpoint, a virtual infrastructure, right? And then we provide value to the end user almost immediately, because we're not doing anything other than just setting that up. How long would that life cycle take?
It's a little bit dependent on what kind of infrastructure or what kind of systems
Say
people
it's
have.
solar panels, just solar panels. Like
With solar, I mean, it's you figure out a couple of questions or 3 or 4 questions you want answered, and then I mean, you could get something up which is modeling that in an okay way in, let's say, a week or so, and to start to get value. If you have, I mean, there's other cases too, because some surprisingly many organizations, they have models already. You don't even need to do them ontology modeling typically. It's just sitting right there. It could be things like OPC UA. There could be so OPC UA is more like a general way of representing information from operational technologies, which is actually represented in the graph. You can just lift that graph and start querying right away. But also there's modeling initiatives around, let's say, these process plants. You have DEXP, which is a standard for these, let's say, digitized, it's called process and instrumentation diagram, piping and instrumentation diagram, I think. It's sort of lining out how things are connected. And these models already exist in industry. So oftentimes it's just a question of lifting that. And when you're on this standard, when you're on DEXP, when you're on OPC UA, when you're on for power distribution, you could be on SIM, common information model. These are, I think, IEC standards.
Mm.
Then the whole process is even automated. You can just lift what you have, and then it's just a matter of setting up that process, but it's totally predictable.
Wait a
So,
minute. But even if you're lifting these things that already exist, don't you have to like, isn't it use case driven? You have a question, you create just enough infrastructure to answer that question, and then you embed the contracts, the tests, the assertions that give you the resilience in your system. No?
yeah, well, of course you would center that project around some questions, because it's no use lifting things if you don't want to if you don't have questions that need answering. But the point is that since these things are standardized and interoperable, it's just quicker to do just the wholesale lift. It can be automated. So there's things like the asset administration shell, which is also it. These things from the standardization organizations or sort of very closely tied to them, there are already defined transformations into knowledge graphs. It's just a matter of lifting it, and then at least for these, for other for the solar case, it might not be that sort of very easy, but it's quite easy still. And then you can start querying the operational data. That's sort of, let's say, often where there's variation is how connected are these industrial asset models to operational data? Is there good data quality pointers to the right time series data to the operational data set? Or do we sort of have to match things and figure out what goes with what? But again, you wouldn't try to match. Of course, if you have this kind of problem that really requires you to match things, you would only match what you need to deliver value.
And at any point that you feel that the reporting, the query is not rich enough, you can go in and you can embed more data. You could resolve information across different schemas, different databases. You can even
Mm,
tie in like third-party data sources,
yep.
like the weather, to build a richer model of like, okay, in the winter we don't get so much sun, so we're not gonna
Yeah,
get that
for
much.
the solar case, there's I mean, very good case for having accurate information about the cloud cover over your plant. So that's something you could drag in from an external source. Yeah.
Yes. Do you have any words of advice for somebody who's right now working in this environment of industrial data? They have challenges day in day out where they have to maintain this brittle system. Where can they get started? And yeah, I'll start there, and then I have another question for you.
Okay. Yeah, I would say that they should they should not sort of try to find the right way and to find the right model, exactly the right way of doing things straight away, which is sort of comes naturally to engineers. So you want to build a solid ridge, you have to start with the foundations. This isn't what we're advocating. Saying start small and see how things work. We're very happy to assist such companies, and we also have, let's say, a network of collaborators that we can use to support you. But I would say start with a small project which is driven by these questions, these needs that you have that you know will deliver value if you have them. And if that's the case, you can very often get to delivering that in a matter of weeks.
And who should reach out to you?
Well, if you're especially I'm very interested. I mean, we're interested in talking to these industrial companies, heavy industries, energy. Typically, if you have some, we find that these companies, they have people who really understand knowledge graphs, and who really see the value knowledge graphs would have for their organization, but it could be hard to sell that project internally. And I think what we could really contribute is to make the value just undeniable and visible from the get-go, from just a minimal investment. So that really helps build credibility and build the case for knowledge graphs. So if you already think that, okay, knowledge graphs is good for my company, we can really get something done. We can really help with that, let's say, value add execution part to demonstrate value.
I think that's I might be a little bit stereotyping the Nordics, but I think that's a very Nordic thing to do. Find how to be value driven and not obfuscate or do things that don't make sense. Uh, at least that's the impression I've received so far.
Well, yeah. Well, we try to be, let's say, straight shooters, and we explicitly say this is our strategy to not do vendor lock-in. There's no tricks here. We want to we have open source. Our commercial model is based around the notion that, okay, we're building software. This is costing money. Of course, it's reasonable also for companies to expect to pay something to have support and to have an organization that can be there for you. But we want to really be
Open.
I mean, open and even, I mean, this is capitalism, competition. So we want to compete on quality and price, these kinds of things. So.
There's a saying, damn, all tides rise to all tides rise together. A rising tide lifts all boats.
A rising tide lifts all boats. Yeah.
So if you're building this open source, standards based platform for scaffolding knowledge graphs, you're opening up the door for labor to upskill in RDF and Sparkle and be able to see and find work in different companies. Companies are not going to be locked in by vendor specific language or infrastructure. So they're free to find something, use it. If they have a different use case, which integrate to something that is more pertinent to their immediate use case.
Yeah.
I mean, I think you're doing a lovely job at making it easy for the industry to advance, because open source is the way forward for everybody to participate together.
Yeah. So that was the sort of the purpose of the PhD, was to figure out how can we do this in a sort of an accessible, easy, iterative way that's sort of in the modern way of doing things. Like I was doing software development for 7 years before I did the PhD. So I was coming to this expecting to work sort of like I've become used to, and found that was a little bit difficult to do. So that's the motivation behind a bunch of this work.
Well, Magnus, thank you very much for coming on the show, and I appreciate you sharing your expertise. And I certainly took away some interesting concepts around digital twins, digital shadows, building platforms, and just doing things that make sense, one step at a time.
Pragmatic. Yeah. Thanks a lot, Joaquin, for having me. I really appreciated it. So I think it was very useful for me to sort of be able to sharpen the message here a little bit, and to clarified a few things for myself as well. So thanks.